Okay, now question number 12. Two firms with constant marginal cost equal to 2 choose the quantity they want to produce by maximizing their joint profit. So they collude, okay? The demand they face is the same as before. The market price and the quantity each firm will produce is which one here? Okay, so collusion, yeah? They maximize their joint profits, sorry. So the two variables are Q1 and Q2. They talk and they decide to fix the quantity they need to produce together. Yeah, they meet and they take that decision. Then price comes from the inverse demand times Q1 plus Q2 is the quantity they want to they will produce together. This is the same as dividing, yeah, the price times Q1 are the revenues of firm 1 plus the price times Q2 is the revenues from firm 2. Okay, minus, well, here we have the cost for firm 1 and the cost for firm 2. We operate, we find this, and then we need to differentiate. Well, be careful here. If you differentiate with respect to Q1 and Q2 and equal it to 0, you will find the same equation twice. Okay? Then you will need to remember that both firms are exactly the same, well, except the fixed cost, but they don't play any role here. So you need to remember this. So you differentiate this with respect to any of the two variables, and then you substitute this condition, because if both firms have the same marginal cost, they will decide to produce the same. Okay, it's not logical other decision. So 11 is the derivative of this with respect to, for example, Q1 minus 2, it goes with the other two, Q1 plus Q2 minus 2 equal to 0. 11 minus 2 is 9 minus 2 Q1, because in the place where Q2 is, we introduce Q1 equal to 0, then at the end firm 1 should produce 4.5, the other firm will also decide together to produce 4.5. Between them they produce 9 units, and then the price it will be in the market is going to the inverse demand. 22 minus 9 is 13 divided by 2, 6.5. Okay, then we find the okay, perfect. So it was C. Okay, well, an action is a kind of, in the sense that we try to approximate to what? Well, it's a kind of first degree price discrimination, yeah, because we try to take the maximum price from a consumer. Yeah, we try to see how they fight for the highest price to pay for every unit we take to this auction, or I don't know how to say it. But, well, let's continue now after this little break with question 14. In the Prisoner's Dilemma game, there is a unique Nash equilibrium in pure strategies. Yes, of course. The Nash equilibrium in pure strategies is not Pareto efficient, of course. Both parties have dominant strategies, of course. So clearly all of the above, because Prešernov's dilemma we should have very clear. Okay, here you have the Prešernov's dilemma. I suppose you've played many times, so you have here to play again if you want. Okay, perfect. This would be the Nash equilibrium, and we see that. Okay, I will tell you something. You know that it could be played with negative numbers, or it could be played with positive numbers, meaning years at jail. Okay, I prefer to play it like this. If you play it like this, you need to choose the lowest number each time. Okay, so maybe I will play it just in case. Well, if I'm prisoner 1 and I think that prisoner 2 will confess, I should confess and go only 5 years to jail instead of not confess and going 10. If I think that prisoner 2 will not confess, I should confess and free. Yeah, free, instead of not confessing and going 2 years to jail. Well, here it can be seen that confess is a dominant strategy for prisoner 1. Okay, now prisoner 2. If I'm prisoner 2 and I think that prisoner 1 will confess, I should confess, because 5 is lower than 10. Okay, I prefer to go 5 years to jail and not going 10 years to jail. Okay, and if I think that prisoner 1 will not confess, I should confess and go free. Okay, now we can see that if both didn't confess, they would be better off than confessing both. That's why Nash equilibrium is not Pareto efficient, as you should know. Okay, then chess and poker are two examples of what? Well, Prešernov's dilemma? No. Simultaneous game? No. That's why they are not examples of Prešernov's dilemma. They are dynamic, or also called sequential games. Okay, so clear. So let's play now a dynamic game. The second perfect Nash equilibrium of the following dynamic game gives the outcome. Well, as we should know, we play backwards. So we go to this node, to this vertex, and we choose computing hard or computing soft. If we choose computing soft, we will win 5. Yeah. If we choose computing hard, we will win 0. So we should choose this. Okay. Now we go up, and now player 1 could choose entry this market, winning 3, or sorry, don't enter this market, winning 3, or enter this market, and afterwards, if player 2 is rational, it should choose this. So I, player 1, know that if I choose to enter this market, I should win 5. Okay, because I hope that player 2 will act rationally. Okay, so I should choose enter to win 5 instead of not enter and winning 3. So the solution should be first player 1 enter, and then player 2 competing soft. Okay, so the outcome is 5-5. Here you have solved. Finding now 17. When two firms collude, this question is very important for me, you know, many of you know why. When two firms collude, they produce their their output together. No. They produce the same quantity. Why? The firms are different. they will make an agreement, okay, that the firm, maybe one firm could produce more and win more than the other one if the cost and so on tell them to do so, okay. The profits are equal. No. They agree to maximize the joint profits. Yes. Okay. This is what co-living means. Perfect. Now, 18. Exam question. The prisoner's dilemma game and the chicken game. What? Well, the prisoner's dilemma game may have more than one Nash equilibrium imperial strategies. Of course, not. The prisoner's dilemma game has one Nash equilibrium imperial strategies. Yes. Chicken game has two Nash equilibria impure strategies. Yes. Yes. So be careful because D says B and C, okay? The prisoner's dilemma game has an equilibrium in dominant strategies. Yes. Because for both prayers, choosing confess is dominant strategy, okay? And the chicken game do not have any equilibrium in dominant strategies. Yes, of course, because if one rider or player thinks the other one will swerve, it then will take the other decision on swerve, and asymmetrically, if it thinks that it won't swerve, he would swerve. Okay. Then here we have both games, but we've played before. I don't know. Sorry, I don't remember if in this video or the video in the first questions. Okay, but we have it done before. So 19, another exam question. Demand for light bulbs can be characterized by Q equal to 100 minus P, where Q is in millions of boxes of light sold and P is the price per box. There are two producers of light, Everglow and Dimlit, both operating with the same total cost function, given by this, okay? Suppose that the two firms independently recognize the oligopolistic nature of the light bulb industry and play Cournot. What are the equilibrium values of the quantity each firm produces in millions and price? Okay, so just we need to do Cournot. Then inverse demand, P equal to 100 minus Q, and now Cournot. As both firms are equal, then we do the maximization problem just for one firm. For example, Everglow. The profits for Everglow would be 100 minus the combined quantity, okay, this is the price, times the quantity Everglow would produce, minus its cost. I think, oh no, I didn't read it correctly. Okay, I thought there were fixed costs, but it's okay. Then we operate here just to convert the differentiation in an easier exercise, yeah, as differentiating here. So 90 minus 3QE minus QD equal to 0. If we isolate QE, we would have this, okay? 90 minus QD divided by 3. This is the reaction function or the best response function for Everglow. Then, as both firms have the same marginal cost, we know that in Cournot game they will produce the same. Then we carry this condition here. We have the quantity for Everglow equal to 90 minus that quantity divided by 3, and we isolate QE slowly, and we find for QE equal to 90, then QE equal to 22.5. Now, the other film, the inlet, will produce the same, and hence together they would produce 45. With these 45 units, we go to the inverse demand and we find that price would be 55. Okay, so it should be A. Yeah, perfect. Yeah. Now 20, another exam question. Suppose okay, this was the second part of that exam question. Suppose now that Everglow manager from the previous exercise guesses correctly that Dimlit is playing or not. So Everglow plays Stackelberg. What are the equivalent values of the quality each film produces in millions and the price? Now, as I told you before in the previous video, I think we need to make the maximization problem, constraint maximization problem from the leader. Okay, now the leader is Everglow because it chooses the quality before, hoping Dimlit will act like this. Okay, then profits are these, yeah, price times quantity minus the cost for Everglow. And now we substitute here again, well, here correctly, exactly here, and we have 100 minus QE plus this plus QD times QE minus its cost. We operate it correctly, and if we differentiate with respect to QE, we have 60 minus 7/3 QE equal to 0. If we isolate QE, we have 180 divided by 7. Okay. Then, if we go to the best response function for QD, we have 90 minus this quantity divided by 3. We operate and we get 150 divided by 7. Hence, together they produce 330 divided by 7, and the price would be going to the inverse demand, 100 minus this quantity, so 370 divided by 7. Okay, so the correct one was A. Now, well, this is a beautiful exercise. I hope you like it. If all of us pay our taxes, it's better for all of us. But if I don't pay my taxes, it's better for me. If we simplify this situation to a country with two citizens, A and B, we could represent the game as a simultaneous game as follows. Okay, I'm citizen 1. If I pay and the other one pays, each of them will 15. Okay, each of us will win 15. If I don't pay and the other one pays, well, I have 0 and the other one has 20. Well, as the situation is symmetric, we write it here 20 and 0, and if we don't pay, we win 5. Okay, we don't have services, we don't have hospitals, we don't have roads. Okay, then the national equilibrium is not pay, blah 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 blah. So let's play it. If I'm citizen 1 and I think that citizens 2 will pay, I shouldn't pay. Okay. If citizen 2 doesn't pay, I think that will not pay, don't pay. I will also not pay and win 5. So be careful, because not paying is a dominant strategy from me. Okay. Citizen 2, if I think that citizen 1 will pay, I could pay and win 15, or could not pay and win 20. So 20, don't pay. And if I think that citizen 1 will not pay, I shouldn't pay to win 5 instead of paying and winning 0. So 5, 5, don't pay. It's the unique Nash equilibrium, and with dominant strategy for each player being not paid. Okay, and we can see that if both paid, they would be better off. Okay, so this is the situation of the prisoner's dilemma. Yeah? National equilibrium is not pay, not pay, correct. The national equilibrium is not Pareto efficient, correct. We can conclude that this game is essentially the same as the prisoner's dilemma, correct. So the answer clearly is D. We can see here another example of that tell us how important the prisoner's dilemma or why is so famous. Okay. Well, 22nd, another exam question. Well, identify the truthfulness of the following statements. The current equilibrium price is less than the monopoly price, but greater than the competitive price. Of course, this is very clear. With a large number of firms in the industry, the current equilibrium industry output goes up and the equilibrium market price goes down. Well, of course, it's true, because the more firms there are, the more we will approximate to perfect competition. So, if I don't remember bad, both were true, yeah? Well, another easy question. Now, another exam question. In the Stackelberg model, the leader and okay, it has a strategic advantage, yes, and it produces a higher quality of output than in the Coulomb equilibrium. Yes, that's correct, of course. But be careful, because A and B could be true. Earns a lower profit than it would have earned at the Coulomb equilibrium. No. If the leader has any advantage, okay, it's reasonable to win more. Okay, so clearly it's A. Another very easy question. Now, another exam question. The Bertrand model, the equilibrium price is equal to marginal cost if all firms have the same constant marginal cost and products are homogeneous. Okay, this is true. We have played Bertrand in class, and I hope there is some. I think I put some examples of Bertrand with this hypothesis that equal constant marginal cost. So we'll see it. Some of the companies might have positive profits if not all the firms have the same marginal cost, even though products are homogeneous. Yes, this is true. And I don't know if I put any example of this, or you have more complicated ones that I give you, but I won't do videos on them. C. Prices generally exceed marginal cost with differentiated products. Well, yes, this is true, but we don't see in class, so but we can think that it's logical, yeah. So we should mark D. I think this is another not too easy, but easy question. Okay, not as easy as the previous ones, but also easy. In the following game, there are two national equilibriums, but one of them is an inferior equilibrium, etc. Well, let's play it. If I'm player 1 and I think that player 2 will choose left, I should... Okay, I could choose up and win 2, or I could choose down and win 2. Okay? Be careful. So, when I have a trail, I should mark both options, both strategies. Okay? Well, if player 2 chooses right, okay, if I think that he could choose right, I should choose up and win 4 instead of choosing down and winning 3. Yeah. Now, if I'm player 2 and I think that player 1 will choose up, I could choose left or right, because anywhere in any of the possibilities I would win the same. Okay, I mark both them. If I think that player 1 will choose down, I should choose right and win 4. Okay, So we have, be careful, two Nash equilibria, but one of them, this one, is an inferior equilibrium. Okay, it's called inferior because it's dominated by this. Okay, well, the unique Nash equilibrium in pure statistics is up left. Now, the Nash equilibrium is period efficient. Well, we have two, so we can talk about the Nash equilibrium, about a unique. We can't. So clearly is A. Okay. Well, 26th. We say that player A has dominant strategy if her optimal strategy dominates the best strategy of the other player. No, this is a strange sentence. Yeah. The optimal strategy of the other player is always dominated by the optimal strategy of player A. No, 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 no. It doesn't. It has nothing to do with the strategies of the other player for my dominant strategies. Okay. There is one optimal choice of strategy for player A, no matter what the other player does. Yeah. Yes, this is the definition of, at least for me, this is the definition of dominant strategy. Okay. So clearly C. Well, let's make a little break and we will continue.